Hi, and now it's the time to provide a summary of the first three chapters of the textbook and um, provide some homework exercise. So I intentionally started the presentation with practical examples just to give us some sense what are the practical ways of collecting data, presenting the data, and all these activities fit into the bigger picture where the structured approach where the researcher or analyst has to follow to achieve its goals. So there are certain steps, logical steps which any data analyst or researcher needs to follow. If either of those steps are not properly followed, the success of the problem solving is gonna be in really big doubt. So what are those steps? Basically, the steps I have presented in this on the blackboard is pretty much similar which textbook presents. There are some tactical differences, but they don't change the entire picture. As we mentioned, statistics is the science which deals with the data collection, presentation, and problem solving. But at the same time, there's a needed structure to follow in order to make these claims true. So what are those steps? First, we need to define the problem. Without understanding what we're gonna solve, we really are not gonna be very useful in that solving that problem. In order to move from the general concept to the practical domain, we need to understand what outcome we're gonna measure and how we're gonna measure. So as we mentioned, without variability there is no statistics. So each outcome, if we perceive to be the same, it has a variability, inherent variability. So there is no exactly the same outcome from the same experiment. There is a variability involved in each experiment. So depending on the variable we are measuring, we could have potentially numerical outcome of the experiment or categorical outcome of the experiment. That changes entire game plan. The really recommendation is to make every effort to present your experimental outcome as a numerical because there are more tools, both graphical and inferential tools, to solve the problem when the outcome of the experiment is numerical. And in other words, there is a more power in the numerical outcome. The third step I defined is the method we are going to use to solve the problem. There are plenty of methods out there, and there are plenty of approaches. So it could be just observational approach when the experimenter doesn't really change the set up the experiments, but rather it observes the outcome which he or she is trying to improve over the time. On the other hand, there are the problem solving oftentimes requires setting up the experiments. So the researcher or analyst has to set the design or design the experiment, which in controlled manner the certain set of factors are being changed such that their impact on the outcome of interest is being observed. So that is a very important topic, and much of this text is going to be concentrated about defining or studying the methods which will help us to solve the problem. Once we are clear what we're going to measure and how we're going to measure and what analysis we're going to conduct, then another important step is we have to collect the data. Certainly, data collection, if not conducted properly, could really throw the analysis of the experiment or in an entire different direction and draw different or wrong conclusions. Once the data collected, we need to have proper analysis conducted, and certainly a part of the lectures I am going to produce will be focusing on the details how to make how to solve or analyze the problem, but it's from practical approach. Relying on the software is really instrumental. So therefore, I would like also to be sure that my students know how to use this software actually for solving real life problems. Therefore, the homework I would like to assign is related in utilizing one of the software. Plenty of software are available. I provided a link to Minitab. Excel could be utilized just to conduct on the selected example graphical analysis of pie chart and histogram. That is going to be the homework for this learning plan. The problem is up to you. You could utilize any data set, but the report needs to be the graphical outcome from the software needs to be included in the report. And just analyzing the problem is not enough. So the results of the analysis certainly needs to be utilized in order to solve the problem. For example, in the real life problems I am encountering on the daily basis, we do conduct a lot of experiments, we design a lot of experiments, but once those key factors impacting the outcome we would like to improve or identify, we have to go and really put controls on those factors. So certainly the solving the problem is another step, which is takes the recommendations or conclusions of the data analysis into the practical domain. So therefore, in order to practically solve problems, you have to follow each step in consecutive order, and that will really maximize our chances to solve real world problems with statistical tools. And again, as a homework for this learning plan 1 for the seminar, I would like to see a problem solved using statistical software. Excel is fine. Minitab, I provided a link, and it's really several clicks away from presenting your data set in the using graphical tools. And again, the graphical tools for categorical outcome are pie chart, bar chart. For numerical outcome, we have much more diverse tool set. It could be dot plot, histogram, other box plots, which we didn't cover, but the complex concept is rather simple. Okay, if you have any questions, just write me an email or give me a call. I will be gladly answering your